that we have defined. So this can happen to entry point 0 and can happen to entry point 4 also. So the next obstacle that we are facing is the simulation at the full chip model is very time consuming. So what happened is the validation team, they do partition the design in their own environment. So they do cluster testing that help them to run the simulation faster and get the validation done faster. So for this design, this is how they partition it. They partition it in multiple clusters. So on the cluster 1, we find that our entry point 0 is in the cluster 1. And the entry point 1 is a cluster in the cluster 2. And then entry point 4 is in the cluster 3. And our asset is in cluster 4. So how to do pen testing in this situation? Because the threat agent seems to come from everywhere in the different cluster. And the data we want to protect is in a different cluster. Let's look at it one by one. So earlier we know that the design weaknesses is in the cluster 1. So since the design weaknesses is in cluster 1, we may want to isolate our testing at entry point 1. But how do we take care of cluster 2, 3, and 4? So we can replace this cluster 2 and 3 by a BFM. Why only one BFM? In this particular design, it so happened that this cluster 1 only see the entry point as 1 because it goes through some arbitration, and then the final outcome that going to cluster 1 is only 1 entry point, but the arbitration is done at the earlier level. So we only need one BFM in this cluster 1. But what happened to our asset because it's still outside the cluster? So how do we take care of it? So one way is we could look at the logic path that lead to this asset. Once we find out the logic path that leads to the asset, we can move this asset into the cluster 1 RTL model, meaning that we replace the path that going to this asset as an asset. And if we and then we write the assertion check on this asset and also on the access control, which potentially can redirect the traffic. And then it can if it influence the path, then the alert message will flash out. So with that defined, our test written, we run the simulation. So this is one example of the waveform that we have. There are a couple of ways to run the simulation. We can run it in interactive mode. We can also run in batch mode. In interactive mode, usually we do it when we still develop the test. We are debugging the test. And in the batch mode is when we run regression. So in a batch mode, if you write those assertion check or whatever check you have, if you feel the script will flag out the error message, you still can catch it. You don't need to always observe the waveform. Okay. So once you run the simulation, if the test fail, meaning the alert message flash out. Okay, the alert message flash out because the traffic get redirected, but it didn't really get into the asset, the path that we want it to go. So we may want to rerun the simulation and maybe fine-tune our test. So we may try at a different attribute on the same type of cycle, or we want to try a different type of cycle. So after we analyze all this, if we find that the design have well protection on this, we may want to move on to different things. But if not, we will continue to rerun the test and to make changes on the test. So if it hit the asset, yes, definitely this is a bug. You will want the design to fix it. So once the design fix it, we want to rerun the test and make sure that the design is robust enough against a new fix. So how can you apply this? So first of all, we need to, I think, before we talk about how can you apply this, you may want to ask who can apply this method. Security consultant who have access to the RTL code, they can apply this, which is very obvious. But can anybody else apply this method? Yes, you can. Yes, you can do it. So how are you going to apply this method? So what do you need? You need an RTL code. You can get a free open source IP. The information is in the link that I shown here. But if you are rich or you want to spend money, or you can get a commercial IP, which a lot of companies that are designing a product, they actually buy the IP from some developer. The next one is get a simulator. Again, there are open source logic simulator. There are also commercial logic simulator. If you don't want to spend money, there are free open source simulator. But you need to check the weaknesses of some of these simulator. Some of them may not be very accurate. But you just want to try it out and play with it, you can try the free one. If you have money and want to spend more, you can get it from a commercial logic simulator. There are some examples on this. There's a logic sim, model sim, VCS. There are many types. You can get the whole list at the link here. And the other thing we want to get is get a specification. Let's say you want to run pen testing on the RTL code. Most of the time, RTL code is so small in the whole system. You need to understand where is this RTL code, this piece of RTL code used in the product. You may want to check out how is it relate to the asset, how is it relate to an attacker, and what are the access control that you can change. So once you get this, you have a better idea how you can attack this RTL code. And if you cannot find, after you read through the spec and find that this piece of RTL code has no relationship at all with all these things, then perhaps you should look for another RTL code that have a relationship to this asset and tracker and access control. And do you need BFM, tracker, test bench, and test? Yes, you need it, but it depends on how big is the scale of your simulation. If you run on the very small piece of the RTL code, you may not need all this trouble because if a small RTL code, it may have only one input. You can inject the vector directly at the simulator. BFM is good because it helps you to apply the input in a way that it meets the protocol requirement. Tracker is good because it helps you to observe the signal. But if you have a small piece of design, you can observe it by your own eye. And test bench, similarly, if this is very small scale of the simulation, you may not really need it. For test, you just apply the vector as a stimulus into your RTL code. But if you work on a bigger design, you will need all this because it will be very tedious to look at the vector one by one. You may have 100 or 1,000 of signal input to the system. You definitely need a BFM, perhaps it's more than one BFM. You may need multiple BFM and multiple tracker to track it. And you need a good test bench so that you can run the simulation more effectively. And so when you have all these, you can have fun, hack the RTL. Okay, next, so for acknowledgement, I want to thank my colleague, Lo Wei-Ki, to make this happen, and all the SICO members for reviewing all these slides. And the next thing is advertisement. So this is Intel product security website. You can visit this website to understand more about Intel product security, or if you want to report the security issue, you can go to this website. Okay, next, despite the stock market, Intel is hiring. And this is my email address. If you are interested in this topic and want to discuss more, you can contact me. Okay. Any question? No question? Okay, thank you.